All right, welcome back. This is it. This is our last part 3 of Breakout 11. This time we're going to implement the ball as a class object and tie up the few loose ends that we have. All right, so let's just jump right into it. I'm going to add a new header file to our project. New item, header. This will be the ball.h. All right, and then I'm just going to copy the header from block. And this will be ball.h, declaration of a ball class object. We need a header guard, so if not def ball h, and define ball h, and then end of. All right, and then we need our class keyword. Oops, not calls, class ball. Capitalize the first letters because it's a pseudo data type. And then we need our public interface and our private interface. And then we're going to need constructors, accessors, getters. Oops. Then the accessor, we have the getters and setters. And then we'll need member methods. All right. So let's look at what properties a ball needs. If we look real quick at breakout, we'll see that, and actually, yeah, we'll see when we create a ball, we'll see that a ball is very similar to a block in that it needs an X and Y, doesn't need a width and height, it needs a radius. And then it's got velocities for the X and Y velocity. We can actually probably see it better in the structure of the ball. So we have the X, Y velocity and the radius. And then obviously our ball has a color also. So let's implement it by copying from the structure, and we'll go to our ball.h. And let's put those properties here. And let's just add well, to be able to add an FGCOGL color, we're going to need to include FGCOGL.h. Right, that's our OpenGL library. Right, and then for this ball size, we could just declare that here as a constant in the ball class. We can do it as a class constant, or we can do it as a global constant. We'll just do it right here. Let's do int ball size equals, and then what did we have in breakout H for our ball size? Our ball size was 8. And actually what we can do is just move all of these properties here. You know what? Actually, I think we'll leave that. I think what we'll do is instead of, because we won't set it, we'll let the game set it. So we won't actually do a constant. And we'll just declare radius. All right, so we need our constructors. We're not going to have an empty ball, so I'm not going to create the default ball constructor. And that's something you can do, is typically we don't create the default constructor, unless we really need to represent the object as an empty object. So I'm just going to create the property constructor for the ball. So just the name of the class, no return data type, and then the properties that we want. And so we can do an a float x, oops, not a flat, but a float y, a float, oops, a float. I'm going to do the int radius, and then I'll do the float velocity x and velocity y. All right, and we're going to see that we're actually going to set those velocities right from the get-go, because we're going to want the ball to start moving as soon as the game starts. All right, and then for our accessors, we're going to have, we need getters and setters for all of our properties. So the getters are going to return float for most of these. So we have a get x coordinate, get y coordinate, going back and forth. I'm going to go ahead and move radius to the end. I like to keep everything in a similar logical ordering. So here we have the property set this way, here we have the property set this way. And this is like position, speed, and then size. Position, speed, and size. So we'll do everything in that order. So float get velocity x, float get velocity y, and then int get, and we could do size. Every once in a while I like to change things up just to keep things, you know, so you see that what choices you can make in the code. All right, so for our setters, remember our setters don't return anything, they're void. So set x coordinate, and here we must pass in a parameter of the data type. So this can be our x, let's just do the value. And then here I'm going to copy and do, so that'll be the y, velocity x, velocity y. That'll be y coordinate, that'll be velocity x and velocity y. And then I just need one more, set size, and that'll be an int value. Now, similar to our block, we're going to implement these fictitious property methods for the dimensions of the ball. So we'll say that at the top we'll have, and they'll just be integers, and these will be used during the collision checking. Top, bottom, left, and right. And those will be calculated properties. And then similar to our player paddle, we're going to need to update the ball's location, and it'll need lag, and we're going to want to draw the ball, and it will need lag. All right. And then we're going to be implementing collision checking, and we'll set that up after we get the rest of this set up. All right, so this is enough to get started. Let's go ahead and create our implementation file for the ball. Oops, what did I do? I did a build. I didn't mean to do a build. I meant to do an add new item, and this will be the CPP file for ball. And then come over here, grab the header, go to the ball, this will be ball CPP, this will be the implementation. And then, of course, we need to include ball h. All right. And then when we go over here, we can grab all of the methods that we've defined so far and paste those. And then we need to put the namespace, the class namespace, in front of all of them. All right, so I'm going to use that Alt, Shift, and down arrow and paste. And then paste, Alt, Shift, and down arrow. And Alt, Shift, and down arrow. All right, and then I'm going to do a global find and replace for semicolon, replace with curly braces. All right, and we're ready to start updating these. All right, so as I've said before, implementing classes is very tedious. Okay, so this is going to be, I'm going to copy this, put it here, here, and here. All right, and then this will be our property constructor. Initial ball location. And, all right, and I can do this typically by going back to the class and copying. And if you guys have worked in some of the Java development environments, it's really nice. They can almost build all of this for you just by defining the properties. So I need to get rid of all of the data types. And then just assign these. This is the X parameter coming in, the Y parameter coming in. This will be this class velocity X equals the parameter velocity X, and this velocity Y is going to be the velocity Y. And then this, oh, no, I don't need to do that. Oh, you know what? I want to make a couple quick changes. I'm sorry, I forgot. I wanted that property here to be size, since we're treating it, calling it as size publicly. And the internal is radius. So this is size, and we're setting the radius to that. All right, now I also wanted to make another change. I wanted these to be similar to the coordinates. So this would be get X velocity and get Y velocity. And then that'll be the same down here. This will be X velocity and Y velocity. All right. And this is just to show that sometimes it actually helps a lot to call the accessors separately from the actual property names. It helps alleviate confusion sometimes. So I'm back in the header file now, fixing those. So this is the set X velocity and set Y velocity. All right. Okay, so for our accessors, remember we're just returning the local property. So in the definition here, return, this is the X position property, return the Y position property. Here we're returning the velocity X. And here we'll return velocity Y. And here we return the radius. All right, and now we're setting those to these value parameters. So X position equals value, Y position equals value, velocity X equals value, and velocity Now you'll notice in the long run we end up not using a lot of the accessors. Value. But we always define them for our class objects, and that helps with the reusability. Like if we wanted to use this ball in a Pong game, it would already have the accessors for the properties if we needed them. Okay, so our member methods, top. Okay, so remember the center, the X and Y of the ball is in the center, the radius gets us out to the top or bottom, left or right. So the top is we would return X position plus radius to go up. I'm sorry, not X, Y. The Y position plus radius would give us the top of the ball. The bottom would be at the Y position minus the radius. The left would be at the X position minus the radius. And the right would be at the X position plus the radius. All right. All right, so for the comment blocks for these, I'm going to steal from the paddle. I'm going to come over here to the paddle, and where's the update? So I don't need all of that, but I can steal some of the text. We're in the ball CPP file, and for update, I'm going to say update location of the ball, each frame relative to lag. But we're going to do the collision checking separately. And then, so here we don't need to worry about direction, left or right wall, just the lag. And then same thing for draw. I'm going to come back to paddle and scroll back to the draw method. And we could see, we could do a circle with border similar to the way we did the blocks with border, but we're not going to do that right now. But you guys could do it if you wanted in your game. So here we're going to draw the ball object on the OpenGL window relative to the current XY and with lag. All right. So how much of this can we update? Well, if we look at breakout, we'll be able to see what things we need to do for the ball during the update. And we're going to see it's not really a whole lot. When we look at this, let's come down to update. There's process input, update. All right, so all of this is going to go away. All we need to do for update is, yeah, we're not going to be adjusting the velocities now. So I'm just going to get rid of that. And so when we see down here, it's really just this down here. So I'm going to copy this for now. I don't want to delete it just yet because I don't want to lose place where it's at. Let's go back here. I'm going to save this and come back here. And we are going to paste that code here. And now we don't need that ball object. We have a local X position. Oops. And we have a local Y position, and we have a local velocity X and a local velocity Y, and lag. That's passed in. And that's it. That's going to update our ball. Okay, and then so for draw, we have to do the same thing. If we look back here in breakout, when we draw the ball, if we come down to render, we have to calculate the ball's new position and then draw it. So I'm going to I'm going to copy that code. I'm going to leave it there so we have a placeholder where to come back to. And I'm going to paste that in here. So here we don't want to modify the actual ball. So what we want is we want to do a float And to keep everything clear, we're going to change its name. We'll just call it cur x. And we're going to say that that's going to be the ball's x position plus its velocity times lag. And then, so same thing here, the float cur y, and that's going to equal the y position plus the ball's velocity y. Nope, we got to get rid of ball because we're in a ball class, times lag. And then we will draw the circle at the current x and the cur y for the radius and the color. And you know what? We didn't implement color. I forgot. Let's come back here to ball H, and we need to implement color. We need a FGCU GL color. We'll just call it color. And then we need that in the properties here, and we can default it. So we do an FGCU GL color, and we can default that to FGCU GL blue. And you can change these colors, that's fine. And then we need a get color, FGCU GL color, get color. And we need a set, void set color, and a FGCU GL color value. All right, so we put it in the constructor. We created a getter and setter as an accessor methods for the property. All right, so we need to implement those now in the ball CPP. So in the constructor, we're now taking in an FGCU GL color called color, and then we're going to set this color equals the parameter color, and then we need and we can copy and paste. Here's the get color. And this will be a ball. If you mess up, it'll be on that. And then we want the curly braces, and we want to return color. And then in the void set color, come back here to ball CPP and put the ball namespace in front of it, and then we just set color equals value. All right, so now we can, when we draw, we now have a color property. All right, so I totally messed up and recorded a whole bunch of the video with the thing on pause. And so I've tried to back it back out, so hopefully I'm back to where I was, and I can splice it together well. But let's see if I can pick up from where I had left off. So last thing, we implemented color, and now we want to start implementing our ball. Hopefully I'm going to go in the right direction with this, but if we look at our breakout implementation, we had some properties in here for the ball. In our breakout header file, we have the ball properties here. We're going to leave those. Here we had cayenne for the color. We were using blue as the default value. That's off the original video game. You can change it if you want. We're going to be changing all of this. Matter of fact, I'm going to change it now. We're going to go with a starting velocity of 40 in the X and 70 in the Y. these are not going to be incremental anymore. All right, the ball size, ball color. So we are going to start implementing the ball here in our CPP file. And to kind of get us started off in the header, we're going to come down to the ball structure and delete it. And that, I'm going to delete that. And now the only structure we should have is the walls, which is a structure with 4 block variables. All right, so now when we go to breakout CPP, we should get a lot of red, which is good. So we're going to start by including the ball.h, the ball. All right, and that clears up a lot of the red, but we'll still have a bunch of red, which is good. That's going to help us. We're going to start here with, we need to declare the ball, but the ball is going to be, we've already started to identify the ball X and ball Y. So here we're going to now call the ball property constructor. It needs a ball X and a ball Y. And now for our velocities, we can do the ball speed X and ball speed Y. And then for the size, the ball size. And then we can just leave the color, or you can change it, or we can do the ball color global constant. All right, and that will get our ball because ball color is probably declared in here as an integer. Where is ball color? Where is ball color? Ball color, yeah, it's an integer. We would need to define it. I don't think we did any of the other FGCGL stuff in here, but we can just do it as an FGCGL, GCUGL color. And let's see if that fixes what it was complaining about. Yep. We can make these ints too. They should be integers for the start. Well, no, actually, ball. Oh no, they're floats. I swore it showed me ints there for just a second ago. Float, float, float. Floats. Int size. Ball color. Yep, okay. So now let's just kind of go with where the red is. So I'm going to come down here. I'm looking at the red here. So, all right, so this we moved to the update method. If we go to ball CPP, that's in our update. So we can just remove that now in breakout CPP. And instead of doing all this, we can now call ball.update and pass lag. All right, we're going to handle the collision checking stuff here in a minute. I'm going to leave that. All of the collision checking stuff we'll take care of in a minute. So we'll come down here. Here's the render. So we did this in the draw method here in the ball CPP file. So now back in breakout, we can just call, let me get from here, ball.draw, and it needs lag, which is coming in as a parameter. And once again, all the collision checking we're going to handle here next. It's going to get moved into the ball. All right, so let's get started on that. We're going to start by moving this collision checking method into the ball class. So I'm going to start with this collision type. This is right now defined here in our breakout header file. So we're going to move this. I'm going to cut this out, and we're going to put this in the ball header file. And it's going to become a public global define. And I'm going to kind of clean these up a little bit. Vertical. I think they look much nicer like this. I know you guys think I love horizontal, the all caps. I don't. It's just academically I need to teach it, but it looks much better like this. All right, now I'm going to come back to breakout, and I'm going to copy this method signature here into the ball header file. It's going to be a new member method. I'll put it down here. And it no longer needs a ball passed to it because it is a ball, or it's part of the ball class. And it's green because we haven't implemented it yet. So I'm going to copy that, and we're going to go to the ball CPP file. And down here at the bottom, I'm going to paste that. And now this is a ball namespace method. And we need to know about a block now. So in the ball class implementation file, we now need to include a block. And this is a quad block object. Alright, and then if we come down here, notice it still doesn't seem to recognize that. So all it wants is, it wants us to tell us that this collision type is from the ball class namespace. Alright, so now we're going to come back to breakout, and we're going to grab this comment block for collision, check, and go back to ball CPP and paste that. And all we have to do is get rid of that ball parameter because we're not passing that anymore. Alright, and then come back to breakout one more time. We got to get all of the guts of this function. So just copy all the guts. And come back to ball and paste all of that right here. And then this will be collision check. All right, now we just need to do a little bit of cleanup. So this is the center of the ball, and these are local properties now that we're in a ball class. So we just get rid of this and this. Oh, and let me fix this. This is now none. And then here, once again, we're still just referencing the center of the circle. So there's the X position, and the X position, and the Y position, and the Y position. And then here, once again, the X position. We're always checking from the center of the ball. All right, so I'm going to fix those in a second. Here's the radius of the ball. And then this would now be our cleaner vertical and our horizontal. All right, so the math. We need to fix this. So what we have to do is in breakout CPP at the very top, we included math defines and the math header. So I'm going to copy that. Actually, I'm going to cut it. We're not going to need it in here anymore. And I'm going to come back to ball. And I'm just going to do it in the CPP file because this is just where I need it. And since these are system, not user, I'm going to include them at the top. And then watch what's going to happen. Because we're in the ball namespace, it doesn't like us to use the standard namespace specifier. So we're just going to remove it, and it is going to automatically search the include files that we have at the top, math.h, to see, well, are these in that namespace? So we still don't need that using namespace standard. It's going to do it for us, but we do have to remove the standard namespace from those methods. And then, of course, pi is now being declared for us. Okay, so there's our collision check method. And then we can come back here to breakout CPP and delete it. All right, so we're up here at the top. Here's the prototype. We're going to delete that. And then we're going to go all the way to the bottom to the collision check method and delete the whole thing. So I'm just going to do Control-Shift-End and delete. All right, and that's the bottom of our render method. And all right, so now here in our update, we have this collision checking going on. All right, so we just need to fix this up a little bit. Here where we do our int collisions, remember this needs to be an int because we're or appending the collisions onto here. Now the first thing we're going to want to do is check for a collision between the ball and the bottom wall. So we are going to do an if statement here. See if ball hit the bottom wall, and that's going to be if ball dot collision check, and we want to pass walls dot bottom. All right, so if that happened, and I'm just going to scroll up a little bit, we're going to set this quit variable to true. So quit equals true. All right. Else we can do the rest of this. So this is going to be collision checking. All right, so I messed this up last time. I need to select all of this stuff all the way down. All this collision checking stuff. I'm going to cut all of that all the way down to the return quit, and I'm going to put it inside this else. All right, now let's do a little more fixing up. So here we're going to check for bottom wall. Oh, quit, not quite. Quit is true. All right, so otherwise we're going to check for collisions against the wall, but once again this is now ball.collision check, and we can get rid of the ball, and we don't need to check the bottom wall. So this would be ball.collision check and get rid of the ball, and ball.collision check and get rid of the ball. All right. Now, when we get here, we're checking for the top of the ball. Has the top of the ball reached the brick start line? And we now have a new method in our ball class that can get us to the top of the wall. So ball.top. All right, it's a method, so we do have to have the parameter list. All right, and then in here, once again, we need to do ball.collision check. Ball.collision check. And get rid of the ball. All right, now notice it doesn't recognize the collision type here, and that we need to tell it that this comes from the ball class, and now it'll find it. All right, the rest of that stays the same. All right, we're going to handle this in a minute. We're actually going to be moving this. All right, so if we do have a collision, we need to do all this, but we want to do all this, we want to adjust all these properties inside the ball class. So we're going to go to ball.h, and we're going to add a new method, and we're just going to call it, it's going to be void, and it's going to be do collision. All right, and it's going to take an integer collisions, which can be non-vertical and or horizontal. All right, we're gonna copy this and go into, let's save and go into ball CPP and jump down to the bottom. All right, and this will be in the ball namespace, and need the body, and then a comment block. And this is going to be adjust trajectory of ball for collisions. All right, parameters, collisions. It's going to be a combo of horizontal / vertical or none. All right, so we're really only going to handle calling this if there was a collision, but we could do a test and say if collisions so we're basically saying if not none. All right, then what do we need to do for a collision? Well, if we come here into breakout CPP, we can just cut all of this and come back here to our ball and paste all that right here. All right, and now we just update. So I called this plural now because it could have multiple collisions in it. And now this is the nicer vertical. And this is the nicer horizontal. Cool. All right, and then this, we are in a ball class, so we have direct access to the properties. And instead of, same thing here, velocity y. And notice we don't have to worry about the logic here because it's all the same. This would be radius. That's one of the nice things about starting out with an API and then moving it to class objects. Radius. Usually you just have to do a little cleanup. And that's it. That'll do our collision checking now. So now back here in breakout, we can just do, we don't even need to do this since we're doing it inside there. We could just do ball dot do collision and pass collision to it. Let me get rid of this. All right, don't really need a comment because it kind of spells out what it's going to do. All right, so the last thing is we need to do collision checking on the paddle. So if the ball's top is reached or greater than the bottom of the rack, we need to check the blocks. Otherwise, else we can check the paddle. So check for collisions with player paddle. All right, so before we do this, remember collision check takes a block, and our paddle is not a block. Our paddle, if we look at paddle.h, is a paddle. But our paddle does have a block in it. We just don't have a way to get to this block right now. All right, we can treat it, it has all the same methods as a block, but it's still not a block, so we can't pass the whole paddle to a method that's expecting a block. So we're just going to do this the easy way. We're going to create a getter that returns a block called get, we'll call it get paddle. And it's going to be read only, in that we're not going to create a setter because we don't want anybody to be able to directly set the block object. So we'll only provide a getter for it, all right? And so I'm going to copy this and come over here to paddle.cpp, and I did that up here in the getters. I'm going to paste that right here, and I need to put it in the paddle namespace. And I probably need to include, let's see, if we go back to paddle H, does this, oh no, this already knew about blocks. It already had the block included. What I need to do is just do the body definition. Right, and then all we need to do is return our private paddle property, which is a block. All right, and I'm going to leave that little read-only note on there. Okay, so now back here in breakout, I can do collisions or equals collision or equals ball dot collision check, and I can pass in the paddle dot get paddle, which will return a block. Alright, and that will just add on any collisions to our current collisions between walls, because we could have a collision with the wall and the paddle at the same time, like the left or right wall. That would be like a horizontal collision and then also a vertical collision with the paddle. Alright, and then we do ball dot collision. So let's see, I think that's all we need to do. Let's see what I've messed up. Let's build. Oh, a lot of stuff. Let's see. Let's just go to the first one. Collision check. This is in ball.h. Ah, see, ball doesn't know about a block yet. We need to include it. Block.h. Block. Quad block object. Alright, so always just fix the first error and then build, because it might clear up all the errors. Look, it succeeded. Alright. So here we included collision check, what needed a block, so we had to include block in the header file. If we look at the CPP file, we were already including block here, so we could actually remove this now because we're including it in the header file, but because of the header guard, it'll just get skipped, whichever one includes it second. Alright, so let's just run and see what we get. Oh, look at that, our ball's already moving, our paddle's moving, we're getting collision checking off the paddle. Our ball doesn't adjust speed. That'll be something I'll put out score handling and adjusting speed as like a supplemental video that you could implement for fun with trick shots and everything. Alright, so let's see what happens if it hits the bottom wall. Alright, there we go. So that's it for the lab. I hope you've enjoyed it. I hope you've learned a lot from it, and I look forward to hearing your feedback on it.